Okay, here we go. So, like I said, we're going to be covering both the rest of the ratios, okay, and our kind of unit circle. Trying to be able to find, like other stuff on the unit circle and all that. Okay. So things to keep in mind here, and in fact, it might be helpful to just go straight. If you have your little cheat sheets here, it might be helpful to get those out. So we're going to add to those too. Okay. So in fact, maybe we'll just do that first. Okay. We focused on Wednesday on sine and cosine. Right? That was our main focus. Sine and cosine. And the reason for that, so you can kind of again think like I messed that up. Okay. The reason why we did that is because every other trig ratio can be found by just manipulating cosine and sine. So if you know cosine and sine of a particular angle, then you can find every other trig ratio that we would want to find. Okay. So that's why we went around our unit circle here and gave all the x and y coordinates at our different points, because x is like our cosine of our angle, and then y coordinate is like the sine of our angle theta there, and that gives you the ratios. Okay. So then how are the other things related? Well, if you remember, or maybe you don't, tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. Okay, so tangent is sine divided by cosine. Okay, cotangent, therefore, well, how do cotangent and tangent relate? They are what? Reciprocal. So therefore, cotangent of theta is going to be what over what? Cosine of theta over sine of theta. Okay. So in other words, if I want to find cotangent of pi over 6, I just need to find cosine of pi over 6 and divide by sine of pi over 6. And that'll give me cotangent pi over 6. Okay? If I wanted to find cotangent of pi over 6, like mentally, right, or do it like, relatively quickly, if I wanted to find cotangent of pi over 6, that would be equal to the cosine of pi over 6, or, does anyone know what cosine of pi over 6 is off the top of their head? Root 3 over 2. And then sine of pi over 6 would be 1/2. Oh, shoot, I just got those back. Did I just do those backwards? Cosine of pi over 6 is 1. Oh, I got my, never mind. Yeah, no, cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. I have it backwards on our little formula sheet here, though. This should be root 3 over 2. And this should be 1/2. Okay, so you might want to fix that. Root 3 over 2, 1/2. But I have all the other things right. That's weird. Okay. Anyway. All right. So that was cotangent. So then what about like secant and cosecant? Well, remember secant of theta is just the reciprocal of what trig function? It's 1 over what? It's 1 over cosine. And then cosecant of theta is 1 over the sine of theta. Okay. And so with all that information, we'll be able to, with this information and this information, our special right triangles, we'll be able to evaluate pretty much any trig ratio that we want. Okay? So, can I remove this? Is anyone still writing from here? We're good? Good? No? Not good. Wait. So, oh yeah. So then how are we going to use this information? Well, first of all, we need to talk about what a reference angle is, okay? And a reference angle is the measure of the angle's terminal side to the x-axis. Okay? Terminal or like ending side or whatever I want to say there. Okay, so it's kind of like wherever you are in that kind of, again, think about the unit circle there. Wherever you are on that unit circle, it's like the closest measure to the x-axis. So again, if I go back, are you all done, Rohan, with what I was looking at there? Very good. So what do I mean by that? Well, if we go back to our little unit circle thing here, okay, if I say, for example, 3 pi over 4. If I go around here to 3 pi over 4, right, there's 3 pi over 4. So that's this big obtuse angle, right, or 135 degrees if you think of it that way. Okay, the reference angle for this, or in other words, what's the measure of the angle between the terminal side right here and the x-axis? What's that measure of this angle right here? 45. So the reference angle for 135 is 45. Okay, or I could go around to, let's say, maybe to like 4 pi over 3 down here. Okay, 4 pi over 3 or 240 degrees. Okay, again, that's the full angle is 4 pi over 3 or 240 degrees. But what is the measure from the end of this angle to the x-axis here? What is the measure? What's that reference angle? 60, right? 60 degrees off the x-axis, okay? So that's the reference angle we're going to use. Or if I come over here, maybe do like 330 degrees, okay? Again, 330, the actual like measure of that, what it would look like would be starting here and going all the way around to right here, okay? But if I just want to measure directly to the x-axis from here to here, what would the measure of this angle be right here? 30, so the reference angle is 30 degrees, or pi over 6 if you like, right, in radians. Okay, so we're going to be using the reference angle to help us identify the trig ratios here, okay, because the reference angle and the actual angle will have the same numbers. So for example here, 11 pi over 6, the reference angle was pi over 6, right? And you'll notice that the x and y coordinates have the same numbers. Right? It's just one's negative, the y coordinate's negative here, whereas the y coordinate's positive here. Or moving back to like the 4 pi over 3, we said its reference angle was pi over 3. Well, if you look here at 4 pi over 3, we have the 1/2 and the root 3 over 2. And at pi over 3, we have the 1/2 and the root 3 over 2. Okay, so you'll see the ratios are the same, it's just whether they're positive or negative. That's the big, kind of thing we have to understand. Or the 135, we said its reference angle was 45, or pi over 4. Again, if you look at the pi over 4, the 45-degree angle here, again, they're both root 2 over 2. Again, it's just the sign, S-I-G-N sign, whether they're positive or whether they're negative. Okay? And so we're going to take advantage of that fact, that the sine and cosine of the reference angle is the same number as the original angle. It's just going to be whether it's positive or negative. That's it. Okay? So here's this little like procedure, I guess, I'm going to try and show you. Okay, so when it comes to evaluating trig functions, one option this first option I'll just show you here, okay, is to, one, ID the reference angle. Again, it might be helpful to convert to radians. Okay, so identify the reference angle, and it may be helpful to convert to radians. Okay, number 2. We're going to then evaluate the reference angle using special right triangles. And then 3, determine plus or minus by the quadrant. Okay, determine the sign, S-I-G-N, whether it's positive or negative, by the quadrant. Okay. So, what you would write down then is something like this. You'd want to, first of all, redraw your special right triangles for yourself, okay, whenever you're about to do work. And this is what I would do You know, whenever I was about to like take a test or something like that at the top of my paper, and I knew there was going to be trig on it, I'd like rewrite it and stuff like that and say, okay, let's see, this is the pi over 6, this is pi over 3, and then there are my sides. And then I'll also draw the 45, 45, 90. Or the pi over 4, pi over 4, pi over 2. Okay, like that. And then if you want to, you could also draw down for yourself this little helpful device here too, whatever you want to say. So it kind of like splits up the it's got your quadrants there, A, S, T, and C. And what do they stand for? Well, in the first quadrant, all trig ratios are positive. Okay? Since both sine and cosine are positive, tangent, which is sine divided by cosine, will be positive. And cotangent, which is cosine divided by sine, that'll be positive. And of course, 1 over a positive is still a positive for secant or cosecant as well. Okay? So all the trig ratios are positive here. In quadrant 2, only sine and its reciprocal cosecant are positive. Okay? And think about why that is, right? The y coordinates are positive in the second quadrant. What trig ratio is associated with the y coordinates? Sine, right? And of course, its reciprocal then, cosecant would also be positive. Whereas the x coordinates in the second quadrant are negative. So cosine and its reciprocal secant will be negative, as well as tangent and cotangent, because they're going to be positive divided by negative, or negative divided by positive, either case. Okay? Quadrant 3, since both the x's and the y's are negative, sine and cosine and their reciprocals, cosecant and secant, will be negative. But then tangent and cotangent become positive because you're taking a negative and dividing by a negative there. Because again, tangent, sine divided by cosine. And then finally, quadrant 4, cosine, so it's a tan, cotan. And then quadrant 4, cosine and its reciprocal secant are positive there, because then you have positive x coordinates, right? Because you're in the fourth quadrant, so x coordinates are positive, but y coordinates are negative. Okay? So that's kind of the organization you can use there. All right. So let's just say, hypothetically, right, we wanted to find the sine of 150 degrees. Let's just run into an example here then. Okay? Let's just say, boom, sine of 150 degrees. Okay? Well, what is the reference angle for this? How far off of the x-axis are we? 30 degrees, right? We are 30 degrees away from 180. 180 is on that x-axis. So we're going to first evaluate sine of 30 degrees. Okay? Or sine of pi over 6, right? And so we'll go right here. There's pi over 6. And according to SOHCAHTOA, sine is opposite 1 over hypotenuse 2. So this is equal to 1/2. Okay? And since the sine of 30 is equal to 1/2, the sine of 150 will also be 1/2. We just have to determine if it's positive or negative here. What quadrant is 150 degrees in? Second quadrant. And sine is positive there. So we're going to keep it a positive 1/2. There's our answer. Okay, sine of 150 degrees is positive 1/2. Okay, let's try another one here. Cosine of 300 degrees. Okay. What's the reference angle here? How far off of the x-axis are we? 60. Again, now in this case, we're almost to 360 degrees. Right? We're almost to the x-axis 360 degrees. So we're 60 away. And so we're going to treat this like cosine of 60 degrees. Okay? Cosine of 60. Well, there's 60 right there. It's right, pi over 3. Cosine is adjacent over hypotenuse, so adjacent 1 over hypotenuse 2. So this is equal to 1/2 here. So this will also equal 1/2. But what quadrant are we in? Well, sorry, cosine 60 is first. What about cosine 300? That's in the fourth quadrant, right? Fourth quadrant, because it's between 270 and 360 there. Fourth quadrant, and so since we're in the fourth quadrant, cosine's positive. So that stays positive 1/2 there. Okay. All right, let's try another one here. Let's do tangent.
tangent of 210 degrees?
All right, what's our reference angle here? How far off of the x-axis are we?
30 degrees. Okay, so this is going to be just like evaluating tangent of 30. Okay, so again, we'll go back to our special right triangle here. Find the 30 degree or pi over 6 angle here. Tangent is what over what? Opposite over adjacent. So 1 over root 3. So this is going to also equal 1 over root 3. What quadrant are we in, though? Third quadrant. Tangent's positive there, so it stays positive 1 over root 3. Or if you like, you can also make it root 3 over 3 if you rationalize it. Okay?
And so there it is.
Taking advantage of those reference angles, having the same kind of like number as the actual angle, but then adjusting the sign for the quadrant that we're in. All right, let's try another one here. How about, bless you, one more here together, and then we'll have you guys try one more. Let's do like secant of 225. Sorry, 215 is not angle. 225 degrees.
Okay, secant of 225 degrees.
Okay. What's our reference? Oh, question, Molly.
How do you know the tangent's positive?
So 210 degrees, that's just a little bit more than 180. So that means we're in the third quadrant.
Yeah.
Tangent is positive in the third quadrant. How do you know the tangent is going to be positive, though, in the third quadrant, you mean?
Yeah.
By the reasoning and stuff. So since in the third quadrant, your x and your y coordinates are both negative,
Yeah.
that means then,
So it's
because you're doing sine divided by cosine, negative divided by negative is positive.
Okay. All right, what's our reference angle for secant of 225?
What's a reference angle? Yeah, 45. Again, we're just 45 away from that x-axis there. So secant of 45, ooh, okay. Well, so we got to think maybe this, like that's 1 over the cosine of 45. Okay. What's the cosine of 45? What is it? Let's go over here, right? There's 45. Cosine is root 2 over 2. So this is going to be 1 over root 2 over 2, or 2 over the square root of 2, right? The reciprocal of root 2 over 2, so 2 over root 2. Like that. If you want to rationalize it, you can.
Make it just root 2. Okay.
But is it going to be positive or negative 2 over root 2? What quadrant are we in? 3. Is secant positive in third quadrant? No, because cosine's negative, so secant will also be negative. So that's negative root 2 over 2. Okay, just like that.
Bless you. Okay.
Now, what about like, actually I said I was going to do one more, but I'm going to do another one here. What about something like tangent of 90 degrees?
Okay. Can we use a reference triangle? Can we use like a reference triangle here, these 30, 60, 90, or 45, 45, 90? Can we use those to help us find tangent of 90 degrees?
I'll get you, Jenna, one sec. Sorry. I'm assuming you have a question about something we're doing, right?
Yeah.
Okay, I'll get you your question. Let me just finish this and we'll do it. I'll go to you. Okay.
Tangent of 90 degrees. There's not a special right
Triangle for this, right? You never really take tangent of the right angle in your special right triangle. So instead, we have to think of this in other ways. So tangent, remember, is sine of 90 over the cosine of 90.
Okay. Try not to get this wrong from the warm-up here again. What is the sine of 90 degrees? What's the x-coordinate
at 90 degrees? 1. I mean, what's the y-coordinate at 90 degrees? 1. What's the x-coordinate for 90 degrees? 0. So it's 1 over 0. So what is the tangent of 90 degrees? It's undefined, right? Undefined. Okay.
Because you're dividing by 0 there. All right, sorry, Jenna, what was your question?
So I got all the way up on the last one.
Huh?
I got all the way up to the cosine, right? The 1 over.
Cosine of 45 equals root 2 over 2?
Yeah, and so I got the 1 over root 2 over 2.
Uh-huh.
Why did the 2 end up on top?
Because 1 over something is the reciprocal of that thing. If you take 1 divided by 1/4, it becomes 4. If you take 2, when you have 1 over something, it becomes the reciprocal. If you don't believe me, right, dividing by something, right? 1 over root 2 over 2 is 1 divided by root 2 over 2, right? Dividing by something is the same thing as multiplying by its reciprocal. So instead of dividing by this, it's the same thing as doing this, which is then you just see the 2 over root 2. Dividing by something is the same as multiplying by its reciprocal. Yeah? Good? Yeah? Okay. So that's that. Okay? So, here, I'll give you guys 2 to try here. I'll just make 2 up, I think. All right, so how about cosecant of 270 degrees? And then let's have you do sine of 11 pi over 6 as well. Okay, I'll just give you 2. Like 1 more minute here. Okay, so cosecant of 270 degrees. This is not a reference angle. Or we can't really do a reference angle here, okay? That's on the bottom part, right, of our kind of unit circle down here. Remember cosecant, that is 1 over what trig function? Sine. And what is the sine of 270 degrees? -1. So this is 1 over -1, or just -1. Okay, so -1 is your final answer there. Alrighty. And what's the reference angle for sine of 11 pi over 6? It's pi over 6, or 30 degrees, whichever one you like to say there. Pi over 6 or 30 degrees. When your angles are in radians, it's really easy to determine what the reference angle is. Okay, when your angle's in radians, it's easy to determine the reference angle. It's just like literally right there, pi over 6. Okay, if you see the pi over 6, even though it's 11 pi over 6 is going to be a reference angle. If you see a pi over 4 is your reference angle. If you see a pi over 3 is your reference angle. Okay, because the 11 there, it just, you can kind of ignore it and get the reference angle from it that way. Okay, so sine of pi over 6. Well, again, we can go back up to our reference angle here. Sine is opposite over hypotenuse. So that's equal to 1/2. Okay, but now 11 pi over 6 is in what quadrant? 4. So quadrant 4 means that it's going to be positive or negative. Negative. So sine 11 pi over 6 is negative 1/2. Okay. So on Monday's quiz, I will give you a heads up time to do your write down your reference. I'll let you write your reference triangles down first, if you prefer, along with this, little I don't know, way to remember the signs, whether it's positive or negative, kind of thing. So you can write down these 3 things if you want to, okay, before the quiz starts, and then we'll start the quiz, kind of thing. Okay, you'll hopefully be able to quickly, evaluate those things. Again, the reference triangles cover the majority of the angles. They just don't cover like the 0 degrees, the 90 degrees, the 180 degrees, the 270 degrees, or 360 degrees for that matter. Okay, so that's kind of helpful. All right, so that kind of helps pull it all together there a little bit. What are some other strategies? The other strategy, the one that I use now, again, this is what I used back when I was in high school and college too, I would say. But now that I practice it more, and some students do this too because they're just better at getting this stuff down than I was back in the day. Strategy that I use now is I basically just like visualize where I am on the unit circle and then determine the coordinates based off of that. Okay, you really only have 4 options about what your answer is going to be. It's going to be root 3 over 2, 1/2, root 2 over 2. I guess it's really 5 options. Root 3 over 2, 1/2, root 2 over 2, 1 or 0, right? Or some combination of those, if it's tangent or cosecant. So, if you're 30 degrees, right, you're further over than you are up, so that's the root 3 over 2 for the x coordinate, and then the 1/2 for the y coordinate, because you're further to the right than you are up, right? You're like more right than up. 45, you're exactly halfway. You're the same amount right as you are up, so that's why it's root 2 over 2, root 2 over 2. And then 60 is a little bit less to the right, more up, so 1/2 and then the root 3 over 2, right? Those are bigger numbers. I don't know if that helps or not, but anyway. So that's what I basically do now is I kind of just visualize where I am on the unit circle with these angles, and then I know that sine is the y coordinate and cosine is the x coordinate, and go from there. Don't know if that's helpful or not either. There's also a way to do it with your hand too. You can use your hand to kind of like you hide a finger. So like for example, if I want to find cosine of pi over 4, I would put down my middle finger here because that is where the pi over 4 is, right? It's the middle angle. So like that's my pinky, ring, middle, index, and then thumb there. And so I say, okay, so that's root 2 over 2, or you can also do the root 2 over 2 this way for the sine and cosine. Anyway, there's a way to do it with your hand too. I can show that to you if you're interested, if none of those other 2 methods make sense. But right, that one's pretty cool too. Yes. So that's all I got for you today. So I'm going to get you guys an assignment here. Okay.